links to my YouTube channel because I get a lot of DMs about that. Please upload the session on YouTube so we can rewatch it. Okay, so I'm gonna be talking in both Arabic and English because, as I can see, I know a lot of people in here uh, are Arab, and we're gonna go both ways. So our session today is our first session. It's week one into the Kubernetes month of January. Of course, it's my birthday month, and I love Kubernetes. So I was like, what would be best to collaborate both my birthday month and my favorite topic, Kubernetes. So we're gonna begin by the first session, or the first week is gonna begin by talking about briefly about Kubernetes, what's inside a Kubernetes cluster. Of course, there is two main things we're gonna talk about, which is the master and the worker node. Happy birthday! Thank you. Uh, and then we're gonna, after the next sessions, we're gonna talk about networking and then observability, and then we're off the technical side, we're going to talk Kubernetes in business because I had a situation in my job that I had to choose either we use Kubernetes or another option. So also we have someone here, Hadia. We're going to tell her happy birthday as her birthday was tomorrow. Was yesterday, not tomorrow, sorry. It was yesterday. Thank you. Okay. So let's begin with session one. Unfortunately, my colleague he's not able to join actually. He just texted me. So inside a Kubernetes cluster, we're gonna talk week one. So we're gonna begin by the table of index, what we're gonna discuss. Of course, we're gonna have a practical part, so it's in index 7. رقم 7 رح يكون جزء عملي. مش رح بس نحكي نظري لأنه أنا ما بحب النظري. And I was saying in Arabic, I don't like all theoretical parts, so we're gonna also have a practical part. So the first index is what is a Kubernetes cluster? Of course, so if we want to understand what's inside the Kubernetes cluster, we need to understand what is actually a Kubernetes cluster. So we're going to begin by that. And then we're going to talk about the actual components, which are briefly two, control plane and worker nodes. And then we're going to sorry, deep dive inside the control plane. And then we're going to take a look at worker nodes. Thank you guys for the birthday wishes. And after we talk about the two components, we're gonna go ahead and actually take a look on what actually Kubernetes does, what does it automate for you, and what it does not do. So we're gonna take a look at what it does and what it doesn't. And we're gonna at index 7, as I said, we're gonna take a very brief but practical part, and all of it is gonna be local. So we're not gonna use any type of cloud vendors, and I'll explain why you can use cloud vendor if you want, and why for this practical session we're not going to use any kind of cloud vendor, and we're going to talk briefly summarize everything and say what's going to be next, and we're going to talk more about our next session. So let's begin. What is inside Kubernetes? What is a Kubernetes site? So understanding how Kubernetes groups run and manage applications. Slides. I just want to talk and express what I know. Would like to join, I would love that. So if anyone has any kind of ideas what is a Kubernetes cluster, I would love for someone to actually speak his mind. So before I go, is there anyone who would like to share his thoughts about a Kubernetes cluster? You can do that in the chat as well. Yes, Lena, go ahead.
The analogy they all talk about is thinking of Kubernetes as a ship, and it has the brain of it. It's the worker. It's two parts mainly: the worker node and the master node. One controls the other. The
Yeah,
control part is the brain, and the other part is where I deploy my app. I choose the architectures. I choose the app itself, the images, whatever. And Kubernetes makes sure all
yeah,
the time that my app is it's in the optimal state. It's in the right size. That's where the head or the brain of Kubernetes is aware. That's it.
yeah. بس بس لينا انت حكيتي انه both parts control each other. Don't you think it's one part that controls the other?
No, no, I didn't mean it. Both parts control the other. No, no, it's like one part control the other.
Yeah. Well, perfect. Thank you. uh, I'm sorry if I'm gonna read your name wrong, but is it Mwalik? You raise your hand. Or Maulik. I don't know. I'm sorry.
Yeah, hello. Yeah,
Hello.
audible to you?
I'm sorry.
Yeah, am I audible to you? I said.
Yes, yes.
Yeah, yes, this is Molek. So I'm just raised my hand because of to what is the Kubernetes cluster you just talk about, right? So basically, Kubernetes cluster is what we are saying. It's an master node and a worker node, where the
Yes,
master node is going to control the worker node, and worker node is going to getting the deployments, what we are deploying the application inside, where the worker node is going to run an application inside their servers, where we said it's a node when the
yes,
master node is going to control them for scheduling and for going to scaling the application. So this is how they are working, but it's getting very large when we are going in the configurations. It's like an scaling the application. We have the having the storage, and we having the role based access control. So because I'm working on this, that's why I know much more.
yeah.
that
Oh, well, perfect description, honestly. Thank you both for sharing your thoughts. And 100% of you said is actually correct.
And happy birthday, Maya, to you.
Thank you. Thank you. Okay, so as both of them said, we have two components, but let's go back a bit. A Kubernetes cluster is like a human body. It's like us right now. So a human body contains of multiple organs, it contains of multiple parts, and all of these parts work together to make us move, to make us eat, to make us do sports, whatever. So we want to go more into this analogy about Kubernetes being like an actual human body. So it actually contains of two parts if you want to think about it. I know human body contains more than just two parts, but let's categorize them in that way. So the first one is your brain, and the second part is everything else. So when you want your hand to move you commands it to move. فلما احنا عنا جزئين، عنا جزء الدماغ وعنا جزء الباقي كل إشي تاني. فأنت لما بدك تيجي تحرك إيدك من اليمين للشمال، دماغك رح يؤمرك بهذا الإشي إنه move from point A to point B, or do that or do this. So this is how we're going to think of a Kubernetes cluster. It's a mechanism that every component is working with each other to give us something we want. So, as I said, I don't like reading into, I like more images and more stories and examples. So, this is a Kubernetes cluster, as all of you said. It contains of two things, a main or a master node and a worker node. As here we can see it says control plane, and we're going to explain more why it's not called, why it's not master, it's control plane, even though they're both kind of like the same. And we have node 1, node 2, node 3, which means, as the analogy I said, we have one brain and multiple parts, but it can be more than just like one brain. Like if you get like hit by a needle or something, you do this. Okay, never mind. I don't want to go too much in biology, but it's like one brain and all the rest of your body parts. Here's the picture of it. Okay, what a cluster is not. So we understand that a cluster contains of two things. It contains of an engine or some type of thing that gives command, and a worker node that actually does what it's supposed to do, that or the things that the orders that it gets from the control plane. So a Kubernetes cluster is not just Docker. So Kubernetes is not Docker, not at all. It serves with Docker, it goes hand in hand with Docker, but it's a different thing. Docker is containers, Kubernetes is a container orchestration tool. So both things are different. There's this similar thing to Kubernetes for Docker. It's called Docker Swarm, but I think Kubernetes is more famous than Swarm, even though I use both. Kind of like the same. There's a bit of differences here and there, but both do the same job if you're not working in production, actually. Okay, so also it's not just Docker. It's not just servers, so it's bigger than just service. It actually orchestrates between containers. We're gonna talk more about it. I don't wanna jump into it. It's not a single machine. So as we said, we have brains, we have body parts. So it's not just the brains or just the body parts. And also, it's not a replacement for a good app design. So if your infrastructure sucks, I'm sorry to say that, but Kubernetes is not going to solve anything for you. And this is a problem I actually had. So before you jump into actually just saying Kubernetes, Kubernetes that, Kubernetes this, you need to make sure that your architecture actually supports this. How so? If you were working on ECS, or if AWS ECS, which is container service, you're going to understand if we want to deploy an application to container it, it has to be container ready. So it has to be able to restart and start on its own. It also needs the ability to help itself, let's say startup configuration, all this type of stuff. It needs to be standalone and container ready. So we can't just give or say Kubernetes is the solution for everything. That's not how it works. So Kubernetes manages infrastructure, not bad app design. So does anyone have any kind of questions till now before I go ahead and continue? Okay. So let's start with our next topic, which is gonna be about control plane versus worker nodes. And as you can see here, we only have one control plane, maybe one or multiple worker nodes. So the big split, let's say it got split by a thunder. So we're gonna take that. Control plane, as we said, decides what should happen. So the brain, it plans, schedules, and monitors. And worker nodes actually executes what needs to be happen, or what the control planes command it to do. So it runs pods, it runs containers, it runs deployments, it runs services, and a lot more. So Kubernetes separates decision making from execution, and this is the line I actually want you to focus on. That Kubernetes actually separates decision making with control plane and execution from worker nodes. So this is inside of a cluster. You can see that the worker node is alone, and it communicates to the nodes on, this is the left. So it communicates to the nodes on the left. As you can see here, we have one master node and multiple other nodes. Let's begin by actually talking about control plane components, which is the brain. And as you can see here, you can actually see the brain on index 3. And we're going to talk about it more. So the components of control plane. Firstly, we're going to start by, I think it contains 4 components, and we're going to talk about them. The component and the most mandatory one is the API server. This API server is actually the entry point between worker nodes and control plane, and without this exclusive component, nodes cannot communicate with each other. So it's like the spine. Yeah, the spine that connects nerves to the body and to the brain. Let's so spine, or you can't walk, you can do anything, and I think probably you would be dead. But so as our cluster, it would be dead. So the API server is just a server that handles communication, entry point of the cluster. All the requests from users, tools go through this API server, and it's going to be validated and processed before any action happens. So it's the entry point. It's the way of communication. This is how you need to think of it. So scheduler, also our next important component. Actually, all components are important. They just work hand in hand together. So choose the best worker node for each pod. So let's say we have 3 nodes, and node 1 and 2 are actually healthy and node 3 is not healthy. So scheduler, it's kind of like a load balancer. You can think of it like a load balancer. It just evaluates resources. I can say it evaluates traffic, just evaluates resource, CPU, memory, and then it distributes it based on what it sees best. So it just like a bodyguard, it checks, are you good, are you not good, I'm gonna send this towards you, I'm not gonna send this toward you. So the other 2 components, also important, controller manager, which keeps the cluster in the design. I want to say that I want 3 pods of this application. Controller manager, I think, would make it possible to just stay at 3 pods per deployment. So it always monitors the resources, it takes action to address these discrepancies, and it actually keeps on monitoring, like, I want this pod to have 2 let's say gigabytes of RAM, let's say, for example, and the controller manager makes sure that all pods have the same resources that is needed. And we're going to see that when we actually deploy an application or a demo app. We're going to see what is inside of a script, of a deployment script, and we're going to see how controller plays. So the last component of control plane is etc. This is basically a key value store, and this is what I want you to think of it everywhere. If anyone tells you key value store in Kubernetes, you go to etcd. That's it. So this holds all cluster state and and configuration data. So it's like kind of a database. I don't want to say it's a database. It's like a place where you store data and configuration data and all of that. So the control plane decides what should happen, not how it runs. Perfect. So let's give a small recap on the control plane components. It contains of 4 components: the API server, which is the main entry point, and the scheduler, which kind of like a load balancer. It decides what's the best node to go to. Controller manager monitors, make sure that everything is okay, and etcd, it's like a key value store that contains all of the configuration data. So basically, this is the control plane. As we said, it contains all of these things we actually talked about, and you can see that it communicates with worker nodes, node 1, 2, and 3. So, index 4, worker node components. So, as we said, we have control plane or master node, and we have worker node. We're going to talk more about worker nodes. It's where your application actually runs inside of the cluster. As we said in the previous slide, let me go back. The control plane decides what happens, not how it runs. So now we're going to talk about how it actually runs. And let's begin. The first thing we have is kubelet. We're going to explain it more. I have a picture that actually explains everything. I'm not going to explain more. But this is the main agent. It's like a small software that talks directly to the API server in the control plane. So we have the main or the master node that has the API server, the entry point we talked about. And the way it communicates with any worker node is using this kubelet. And I'm going to show you in the photo this. So container runtime, it's what it actually runs. So it might run containerd or Creo as there is. It runs actual containers. It pulls the images and starts containers and manages their life cycle. So we either have containerd or Creo, and we have something we call kube proxy. So basically what it has to do with network traffic, it manages routing and load balances. So we remember we talked about the scheduler and the control plane, but the scheduler goes more about resources, and kube proxy goes more about network and trafficking. So this is kube proxy is an actual load balancer, let's say. And the most important, it's not the most important, again, it's one of the main components, is the actual pods, where the application actually lives. When we deploy inside of a pod. So containers are inside of a pod. So worker node don't decide, they just execute. Yes, this is the actual picture I wanted to show you. So as you can see that the worker node on the left and the master node on the right, we have kubelet communicating with kube API server, and that's it. It cannot communicate in any other way. We can see that master node has etcd, which is the key value store. We have the controller and we have the scheduler. And for the worker node, we have container runtime, which it can be Rocket or containerd, as we said, Creo or Docker. So we have multiple options. But I think the most famous ones are Docker. Okay, so what Kubernetes automate for you? And this is really important to understand. So we understood the actual concept of a Kubernetes and what's its components, but when can we actually use and not use Kubernetes? So the operation tasks Kubernetes actually handle for you, so you don't have to. So I don't want to go too much because I'm gonna actually talk about them again in the practical part, specifically self-healing, scaling, and all of that. So the first thing we're gonna talk about scheduling. Remember, scheduler and control plane. It has the same concept. Places pod on the right nodes based on resources and constraints. Self-healing. It restarts the pod if it's unhealthy or if it was deleted by mistake. We're going to see that. Um, Scaling, you can use replica sets, so you can scale the containers up and down. And I think there's this, it's not new, I just recently heard about it, which is KEDA, KEEDA, which is the serverless version. We also have rollouts and rollbacks. So if you want to update the application, you can do them gradually, like container up, container down, blue-green deployment. Or we can go back to the previous deployment if something wrong happens. So either we can, when updating the application, we can do it gradually and gracefully, or we can actually go back to the previous state where it was working and the new update is actually not working. So service discovery and load balancing. As we said, we have two things that actually helps us with this. It's scheduling, or the scheduler and the control plane, and we have kube proxy, which handles the networking. We also have more. We have load balancing and actual like, let's say it's networking protocols. Inside, we're going to talk about them in the next week's session in Kubernetes and networking. We're going to talk more about how the request flows and all of that. So you describe the desired state, and Kubernetes keeps it true. It keeps and makes it true. This is what I wanted for you to understand. These liners at the end of each slide, it describes everything that is in the slide. So what Kubernetes does not do. We talked about how Kubernetes, you decide, you specify what you want, and Kubernetes does it for you. and what Kubernetes does not. So it does not have anything to do with your application code. So if the application is faulty and there's not clean code, Kubernetes is not going to fix that for you. And as I said in the beginning of the session, if you had bad app design, Kubernetes is not going to solve that. I also mentioned about the ECS example. If you want to move to AWS ECS, you have to make the actual application container ready. In regards of starting the application or the configuration of the startup, everything, it has to be ready. So it's also, as we said, it's not going to design your application architecture. It will not help you decide how your application work logically. So if your application actually works and it's deployed on Kubernetes, but it's not performing in the correct way, putting aside it may be a resource problem, but if it's something logical, let's say this is a code problem. So we're gonna go back to number one, which is it's not gonna fix your code. Uh, yes, automatically make bad apps scalable. It's not gonna help you do that, and it's not gonna replace good engineering practices. So it's a tool that will help maintain a state if an application was container ready. So you are still responsible for application security. You're still responsible for secrets. You're still responsible for, let's give, for example, if you have any hard-coded secrets or environment variables inside of the code, you are still responsible for these. And performance tuning and resource planning. So if you know that your application needs 2 vCPUs, you need to actually maintain that. You need to specify your application actually needs 2 vCPUs. It's not a guessing game, except if you're using KIDA, the serverless Kubernetes one. Data design, backups, and migration. Yes, of course, these are on you. It's not gonna be done by Kubernetes. Testing, CI/CD pipelines, and release strategy. Of course, these are on you. Kubernetes just deploys the application. It's not gonna help you with any kind of release management or CI/CD pipelines or Jenkins pipelines. Let's give, for example, or Bitbucket. And of course, observability, observability decisions, which is and what to monitor and why you should monitor this. Should we monitor the resources inside the pods, or we shouldn't? Should we put alarm once a pod starts restarting, or we should not? So all of these, you are still responsible for them. You still need to have some responsibility over Kubernetes. It's just you need to understand what type of responsibilities you need to have. So before going to index 7, which is the practical part, does anyone have any kind of questions before we go? Because I have another slide for the lab. Sharing this. Yes. I'm sorry, I forgot your name. Maulik or Molik.
Okay, yeah, yeah, it's a Molek is fine.
Yeah,
Hello. Yes, so I
yeah,
need to know it's like in replica set. So what it is because I'm working on, but I'm still confusing about the replica set and the cluster having the desired number of replicas, right? So
yeah.
what it is so from your end. So I need to know that one.
Okay.
I'm still confusing about replica set.
So, have you ever worked with AWS autoscaling group?
Yep, yep,
Okay.
yep.
Replica set are kind of similar to AWS autoscaling group. Not similar in the way that actually autoscaling group based on some type of metrics, it scales up and down EC2 instances, for example. Replica set does that for you, but in a manual way. So I'm gonna be showing you in the practical part that you
Okay,
can set a replica set to replicas equal 3. So you're gonna have 3 pods. And if you try deleting one of these 3 pods, it's gonna generate a new one, and it's gonna keep having 3 pods unless you deleted the actual deployment.
okay.
I'm gonna talk about it more in the practical part. So,
Yep.
do you have any kind of other questions?
Yes, the question is like in interview we are getting a question is like what is replica set. So that is the thing I need to know. It's a proper definition for that, so I can explain them about replica set because they are asking the question.
Okay, so a replica set is some type of controller that ensures that certain number of pods are there, and it helps prevent deletion of pods. So, as I said, if you set replicas to 3 and you try
Yep.
deleting one of these pods, it's gonna generate a new one instantly. So this helps you with fault
Okay.
tolerance, it helps you with high availability, it helps you with all type of these stuff. So it's just a
O-
thing that ensures certain number of pods that you specify.
okay, that will run every time you say the
Yeah,
three number of fours.
yeah,
Okay, got it, your answer. Thank you, Maya, for your detailed explanation.
thank you. Okay, so both the slides, it's just a quick note, both of the slides and this Notion page are listed on my GitHub account. So if you're interested in actually doing this Kubernetes lab, you're gonna find all of the details listed, or the actual PDF inside of my GitHub, and I'm gonna share it at the end of the session just to be sure. So we're gonna talk about our basic lab. In this lab, we're gonna actually deploy an actual application. It's really simple. It's just an Nginx application, but this can go a long way with any type of application you're actually imagining, and we're gonna do it locally. So we're gonna. I think maybe some of you are gonna have this question: why not do it on cloud? And I say I would love to do it on cloud, but I actually want you to understand the control plane part and the worker node part, because cloud vendors actually take care of the control plane. So AWS have a service called EKS, Elastic Kubernetes Service. I think you pay 75 per month for them to control the control plane. They take care of the control plane, they take care of everything. You just need to deploy, manage resources, less management overhead or operational overhead. If you're going into production, you can choose AKS, which is Azure Kubernetes Service, EKS, Elastic Kubernetes Service for AWS, or JKE, which is Google Kubernetes Engine. You can choose whatever you like, but for now, we're going to deploy it locally, and we have some prerequisites to do that. So I'm using a Mac. If you're using Windows, I'm going to also tell you how to do that, or on Ubuntu. So if you don't have Homebrew, it was my case, you have to install Brew. Can I actually share two screens together? I don't think so. Okay, we're going to talk about it very fast, and then we're going to go ahead. Yes. So if you don't have any kind of Homebrew, install Homebrew. We're gonna need some type of Docker CLI. For Windows and Mac, you can install Docker Desktop. It's fine. I choose not to because it takes a lot of resources, so I just installed Docker CLI. And we need a runtime for CLI, so I kind of choose Kolema. You can choose whatever runtime, a container runtime you feel comfortable with. So we install Kolema, we started, and we check if it's running. I'm gonna show you guys all of this. We also have kubectl, or Kubernetes CLI. Yes, so we have kubectl CLI. It's the way we write Kubernetes commands. So we need kubectl as or kubectl, people would say. So we need to install it and actually make sure that it's running. And last thing we need to install, sorry, Minikube K3s, or I prefer Minikube or K3s because it's the lighter version of Kubernetes. So I personally installed Minikube, but you can use also um, K3s. We need to set the driver for Docker. So as if you remember, we had many options. We had Creo, we had Docker, we had Rocket. So I chose Docker because, as I said, it's one of the most famous ones. And we can like check it by actually doing a command, which is to get the nodes that we actually have. So final checklist, we need to check Colema status, Docker info, Kube version client, and kubectl get notes. Sorry. So let's do that. Let me share my. Where is it? Let me share my terminal. Can I share my terminal? If it's not, I hope so. Windows, entire screen. Oh, I need to restart my actual application. So guys, I may leave for a quick second and be back, but I need to restart the Chrome because I need to give it access. So BRB in 1 minute. Sorry guys, I'm back. Okay, so as we were talking about, I wanted to share my. Why is it not working? I actually opened it. Sorry guys, I'm having a bit of an issue with sharing my screen. So yeah, so I think now it's gonna be working. Okay, let me. So I'm getting used to Mac. Okay. So here's my terminal. Thank God. So the first thing we wanted to actually is Kolema status. We wanted to check if it's running, if everything is okay. So as you can see here, it's using container Docker socket, container D socket, and as you can see here, runtime is Docker because we actually set the runtime for it to be. We actually set the runtime for it to be in Docker. And the next thing we wanted to check is let's do that. Yes. Here's Docker info, or you can check like, sorry, Docker version. Yes. So we have both Kolema and Docker running for now. We can check kubectl version, and it's the client edition. So kubectl version, oh sorry, client, version client. So as you can see here, we have client version. And then the last thing we wanted to test is we want to get the actual nodes. So kubectl get nodes. And you can see here that Minikube is actually rolling and it's running. So yes, I've tried it 17 hours ago and it's ready as well. Okay. So for us to actually deploy an application, we need some type of YAML files. The first YAML files we need is a deployment YAML file. So it's just going to be, I'm going to send it on the text right here. It's going to be deployment.yaml file. This deployment.yaml file is going to contain all of the specification that we need. What type of deployment do we need? What resources should we use? What ports do we need? And so we can do that. We need to either use Vim or Nano. I don't think I have Vim installed. So deployment.yaml, I do have Vim. And we're gonna use, I'm gonna just copy and paste actually the actual deployment and talk about it more. So In Vim, or in this deployment.yaml file, we have four important characteristics or components. The first one is gonna talk about API version. This is the most important one. It's gonna be there if you write secret.file, service.yaml file, deployment.yaml file, replica set.yaml file, even pod.yaml file. Every one of them is gonna have these four important content. The first one is the API version, which is for my case is API v1. We're gonna have the kind. This is gonna specify if we're using a deployment, if we're gonna be using a replica set, if we're gonna be using a pod, a secret, um, ingress. So kind specifies what this YAML file will do. So for this YAML file, it's gonna be a deployment. We're gonna also have metadata, which is data about the data. The name is gonna be demo app. The spec, which is the specification, and this is gonna talk about specification of the containers and the pods. API kind, API version, kind, metadata, and spec or specification. In the specification part, which is the most important part, where you specify what you want, we have replicas, which is equal to 1. So we're going to have one pod. And this is a part of the replica set. So we are going to have replicas equal 1. It's going to just be one pod. We're going to scale it to 3 later on. We're gonna select or match labels, app demo. We're gonna talk about it more. I think I'm gonna do more sessions on the YAML scripting of Kubernetes. It's gonna be a good idea. And if you go down to the spec of the spec, you can see container. The name is gonna be Nginx, and the name and the image is gonna be Nginx. So it's gonna pull Nginx image and deploy it as port 80. This is what I wanted to show you, that we can specify whatever we want inside the deployment application. So let's save this and let's apply it. So how do we actually apply anything? If it's deployment, if it's replica set, if it's service, we need to apply it using kubectl apply -f and specify the YAML file. So if you want to apply, if you want it to actually work, you need to apply it. So kubectl apply. I would guess -f is force. I don't have anything in mind if it's not, and deployment.yaml file. So as you can see here, the demo app has been created. Would anyone have any kind of guess on how we can check if the deployment is running? It's using kubectl, of course, but how can we check what is it, or how can we use if command? Describe command. Okay. Yes. Can use describe, or the one we use to test if kube CLI is running. I give you a hint. Mulek, you're raising your hands. kubectl get pods. Yes, we can do kubectl get pods. I want to check the deployment though, not the pods. Get deployments. Yes, thank you, Christine. So we can do kubectl get deployments, and you can see here that demo app of the age 66 seconds ago, one is available, and as we specified in the container, we have I don't think I have it. So we specifically said that we want one replica of get deploy all namespaces. It also can work, but we're not looking through namespaces for now. We're gonna be only look for deployments. So as we specified in the deployment.yaml file, we specified that we need one replica of the deployment. So, and we're gonna actually see this one pod. So get pods. Where is it pod? Yes. So here's the name of our pod. Here's the age, and you can see it's running. But if you have any type of problems with your pod, it's gonna give you here crash loopback or it's restarting. Do I need Coloma on my Ubuntu machine? And could you explain in a moment why do we use it again? Yes. So I don't know if Coloma is good with Ubuntu. Honestly, I haven't tried it. I only saw Docker and kubectl and it works on Ubuntu. But you need a runtime for Docker, so it needs like uh, it's a container runtime, so you need something to run the container, and Kolema helps actually run the container on my Mac. I need to check for Ubuntu what they use. Also for Windows, it's WinGet, I guess, Windows Get, and you can install all of the things I listed. Okay, who said describe command? Yes, Muhammad. We're gonna use the describe command to get more info if we need it. So kubectl describe pod, and we can like choose this pod. And you can see here that I wanted kubectl to describe a pod, which is this pod right here. And as you can see here, it runs on Minikube, which is the one we installed. The label we set, it's app demo. And you can see it's running. It has its own IP. It's controlled by a replica set because we actually specified replicas inside of the deployment app. And you can see here the container ID and the image is Nginx. And we also specified that it needs to be on port 80. And you can get also more info using the describe command. So the describe command gives you more in details than just the name of the pod actually running. So we took um, three things, maybe more. So we talked about deployment.yaml files. It's a place where we specified everything in it. It has four main components: API version, kind, and the kind says if it's deployment, if it's not. We have metadata, and we have spec, which is the specification. After we created the deployment file, we apply it. So kubectl apply -f deployment.yaml file, service.yaml file, secret.yaml file. We need to apply it. And if you're using a pipeline, it's kind of different. The pipeline actually applies it for you. Maybe you're using Helm as well. So Helm's apply it for you. And we talked after we deployed the application, and we talked about how to get deployment. So kubectl get deployment, kubectl get pod, and describe the pod. So now we're gonna talk more about scaling the application, and this is where here we can also run the describe command on the deployment. Yes, exactly. Let's do that actually. So kubectl describe. I think the deployment is called demo app. Deployment demo app error. Oh, sorry. Okay, so here, as Christian suggested, we can also have more details into the deployment. Now we're gonna work on scaling the deployment. So as I'm saying, scaling the deployment is gonna be kubectl scale deployment. So we're gonna do that. So it's just as you say it, you're gonna write your command, kind of. It makes sense. So kubectl scale deployment, and then we're gonna name the deployment. So our deployment is demo app, and we're gonna specify replicas. So as we said, we specified in the container that's gonna be one. We can yeah. Yes, so as we said that replica is gonna be one in the deployment YAML file, now I'm gonna make it to 3. So as you can see here that deployments.app demo app has been scaled. Let's get the pods. You're gonna see now 3 pods are running. 2 were generated recently. Oh, sorry. 2 were generated recently due to the scale command that I did. And if I got the deployment, you're actually gonna see instead of 1, now it shows 3. So if we want to actually scale down, we're gonna have to do the same command. So kubectl scale deployment demo app, and then you can specify replicas equal to 1. Let's put it back. And when you get the deployment, it's going to go back to 1. So you can either do that manually, which is of course never preferred. It's not preferred. It's not even best practice. It's just for the demo. Or you can use some type of triggers that scale up in your application. So now let's try and expose this application. We're gonna try and access it via the web browser that I have. So we're gonna have something called service.yaml file. So vim, let me go with nano this time. Service.yaml file. And this YAML file will gonna expose our container port using something called a cluster IP. Again, I'm not gonna go talk about what does it mean, what the cluster IP means. We have more. We have node port. We have load balancer. I'm gonna go deep in them in the session next week. Just gonna go by them. So as we said, we have 4 main categories. We have the API version, which is v1. We have the kind, which is service. The other one was deployment. Metadata, we chose demo services. Specification, selector, demo. Ports is going to be on port 80, target port 80, and the type is cluster IP. Again, cluster IP, we're going to talk about it in the next session. So exit and save. Again, we need to apply it to make it work. So we're gonna do this again. Keep cuttle, apply, -f, service.yaml file. And the service has been created. So if we want to get the service, get SVC. Of course, it's not service or deployment like the one we were before. You can see here based on what's specified where it's gonna be running on port 80. Because we specified in the YAML file to run on port 80 and to use cluster IP has been doing. Okay. Let's see what happens, and this is really important. Let's see what happens if we actually delete a pod. So let me clear the screen, sorry. And we're gonna try. And if I remember, I'm gonna scale it again. Scale deployment better so we can see the actual thing. Scale deployment demo app. And we're gonna set the replicas to 3. And then we're gonna get the pods. And you can see here we have 3 pods. 2 of them are still not running because I'm very fast. So let's get them again. Now they're running. And you can see one of them has been here for 10 minutes and the other are for 12 seconds. Okay, so now let's try to delete kubectl, delete pod, and we're gonna give it this one, the first one. Yes, so now it's deleted. Let's try and get it again. You can see that because we set the replicas for 3, it's gonna stay 3 no matter how much you delete this pod. So as you can see here, it was both 12 and 12. We deleted the first one and it's set. It gave us another one 4 seconds old. This is what replica sets do. Yes. Okay, so this is what replica sets do, and if we let me try and see what else we have. Yes, so we want now to open it on our browser, but because it's running on 120, if I open localhost, I have a question. Will this session be recorded? I will upload it to my YouTube account. So let me stop sharing and reshare the screen. Here the window. Okay, so uh, I'm gonna share my screen. Give me one moment. Having networking issues. Am I still having networking issues? Okay, so now we can see actually when I put localhost 8080 on my browser locally, of course, it's gonna open me the Nginx server that we deployed using um, the kubectl command. Now work fine. Perfect. So briefly on what we did, we created a deployment YAML file. We applied it. We checked the deployment. We checked the pods. We scaled up and down the pods. We tried deleting a pod and we saw how self-healing and replica sets work. And then we deployed a service.yaml file to help us expose this application. And then we forwarded the traffic from 127 to port 80 to the local host so we can access it via the web browser locally, of course. It's not going to be accessible to the public. And now we can actually see Nginx working just fine. So uh, if if we want to ask what we have learned, sorry, let me share this slide. Where is it? Yes. So if we ask what we have learned, that Kubernetes manages application declaratively. So we say what we wanted to do, and it will do it. It scales configuration. Scaling is it's configuration. Sorry, it's not infrastructure. So you just type kubectl scale deployment, and you specify the replica number. And services abstract pod lifecycle. So when we expose the actual pod, and self-healing is built in, so you don't have to configure anything for the self-healing or for the replica set except the actual replica set. You have to specify it for 1, 2, 3, or 4. Okay, we have still. Does anyone have any kind of questions for now? Yes. Okay. So, clear. Thank you. Okay, so if you want, I'm sorry, this slipped out of my mind, but if you want to delete, let me share my screen for a moment. Share my screen on the terminal. Yes. So if you want to actually, let me stop the forwarding. If you want to actually stop the deployment or stop the application, you can say kubectl delete deployment, and you can specify the app. Yes, and then you can delete service. What is it called? I forgot. Wait, kubectl get service CSV. Sorry. Yes, it's demo service. So let's take this and delete it. Or is it SVS? SBC, sorry. And we specify it, yes. So now if we try to get deployment, kubectl get deployment, we're not going to see any deployments here. Yes, this is what I wanted to show you. So you can delete pods, but you can delete deployments. Let me share my screen on another thing. Okay, so I had the lab worksheet listed in the slide. I'm gonna share the. Actually, let me share it with you now. If anyone is interested, I'm gonna share it in the chat before I forget. Yes. Okay. So the last thing we're gonna talk about today is key takeaways and what's next. And the key takeaways we talked about is Kubernetes. It's not just containers, it's a control system, it's an orchestration tool, better wording, container orchestration tool. And you describe the desired state, and Kubernetes makes it true or keeps it true. Control plane decides, worker node executes, failures are expected, and self-healing is built in. So failures are expected, of course, if you have um, even infrastructure issues, if you have not just code issues or bad design issues, if you had bad infrastructure, it's gonna show some problems. Scaling and reliability is handled by configuration, not servers. So everything is going to be handled to you. You only have to specify what you want. So what's next? We're going to talk about Kubernetes networking or Kubernetes in networking. We're going to talk about pods, services, ingress, and traffic flow, how requests traffic, how applications talk to each other, how traffic enters and moves inside of the cluster. We're going to talk about the default network and when networking design matters for production. Yes. And that's it. I'm gonna stop the recording now and I'm gonna wait for anyone. I'm gonna have a Q&A session if anyone is interested talking about it.